Okay, so now
Okay, then.
okay, it's fine. I'll record, it's fine. So, remember, remember we spoke about the integral of ln x, the x, we spoke about the integral maybe of ln of x, let's say plus 1, and the x, let's talk about the integral of ln of, let's say, x squared plus 1 dx. Number 4, maybe let's talk about the integral of ln of what? Let me see. Let's say 2x plus 1, right? dx. So, like I said, to integrate this, you use the same technique throughout. So we were talking about this, and I said to integrate this, you can use the integration by parts, of which you have the integral of u dv, which will be equals to uv, subtract the integral of, we interchange now v du. And I said to you that if we want to solve this question, which is number 1, the integral of ln x dx. So now I said to you, this part of the equation from the integration equation, this part's supposed to correspond with that part. So meaning at this point in time, we can simply tell that the u will be the same as, it's supposed to be ln, not this thing, ln of x dx, right? Let me fix it. So we're supposed to have ln of x dx. So now, meaning u, which is this part over here, it's going to be the same as ln of x. And therefore, dv, which is this part over here, it's going to be the same as dx, which is this, right? So meaning using this equation over here, got my writing. Using this equation over here, let me rewrite that, ln x. Using this equation over here, we can determine du with respect to x. So meaning the derivative of ln x, we know that it's going to be 1 over x dx. This is how we derive this, right? And therefore here, in order for us to determine v, we're going to have to integrate this. So to integrate this derivative of dx, we're going to have to bring x back. So now using all of this information over here, we're going to plug this information onto this equation. So remember, we said the integral of u in this case is the same as ln x, and then dv in this case is the same as dx, which is the same as this thing over here, which is the question that we want to solve, is equals to our u. We said our u is going to be ln of x. And then our v, we said our v, it's going to be x. Subtract the integral of our v. Our v, we said it's going to be x. And our du, we said it's going to be 1 over x multiplied by dx. So we can see that x will cancel x. And then now here we're going to have x ln of x minus, here we're going to have the integral of dx. So now we have x plus ln of x. What is the integral of dx? It's going to be x plus the constant, because we are dealing with the indefinite integral. And therefore now here I'm going to take my x outside of the bracket. I have ln of x subtract 1 plus c, which is the constant. So now we can see that the integral of this thing over here is going to be the same as that thing over there. Even when you use your equation, I mean your formula sheet, you will get it like this. But here we just use the integration by parts. The reason why I'm doing this is because I want you to understand that when you have questions like this, when you want to solve questions like this, you always apply the same thing. Now, based on your question, Mapupa, if you still there, we said that you said you wanted me to help you with this question, right? Our question was, they said we need to determine dy over dx, which is equals to ln of 2x minus 1, right? So basically here we were given the ordinary differential equation, so we use separable, right? So let's separate the variables. So on this side of the equation, we're going to have dy, which will be equals to ln of 2x, this is bar, minus 1 bar, dx. So basically, we need to integrate both sides of the equation to get the solution. So meaning we want to integrate this part over here. We want to integrate this part over here. And how are we going to integrate this? The very same technique that I applied over here, we're going to use it, okay? When you get questions like this, always know that this is the technique to go about. So, because the thing is, you won't be able to use your formula sheet by just looking at this. It's not there on the formula sheet, so you're going to have to use integration by parts. So now let's focus only on this part. So I said to use integration by parts, we're going to use the equation that says the integral of u dv is equals to uv subtract the integral of v du. Remember, what did I say to you? I said this thing supposed to correspond with that thing over there. So that means we're going to let our u to be equals to how much? The coefficient of dx, which is the coefficient of dv there, meaning our u, we're going to let it to be ln of 2x subtract 1. And therefore, the dv, we're going to say our dv will then be equals to how much? Will be the same as dx. And therefore, now, what I'm going to do over here is I'm going to use this equation over here, meaning I'm going to differentiate this equation. So now how to differentiate this? You're going to say du is equals to, I'm going to differentiate this thing that is inside. Ne? What is derivative of 2x minus 1? Derivative of 2x minus 1 is going to be 2. Divide by, and then this thing you're going to write it as it is, which is 2x minus 1. Even when I go back, even when I go back over here, from this equation to there, we differentiated, meaning what is the derivative of x? It's going to be 1. And then you're going to write x as it is there at the bottom. You see, it is still the same thing. So here we're going to differentiate 2x minus 1. It's going to give us 2. And then we're going to write 2x as it is there. Happening now. We're going to write 2x minus 1 as it is there at the bottom. And then we're going to get this. And therefore from here, we're going to integrate this equation. So what is the integral of dv? It's going to be v. What is the integral of dx? It's going to be x. And therefore this information, we're going to substitute it onto this equation. So meaning, but we don't need this side, right? We only need this part, of which will correspond with this part. So now we have y on this side is equals to, now what is u? We said our u is going to be ln of 2x minus 1. And then what is our v? We said our v is the same as x. We substitute x over there. Subtract the integral of v. We said v, it is x. Du, we said, oh, by the way, let me not forget dx over there because we're deriving in respect to x. So now du is going to be the same as 2 over 2x subtract 1 multiplied by dx. Now we can continue with this equation going forward to determine the solution. So now this and this here, we're going to have x ln of 2x subtract 1. Subtract here, we're going to have the integral of this multiplied by that will give me 2x divide by 2x subtract 1 multiplied by the dx. Now the question is then how are we going to integrate this? Now this is simple. To integrate this, we can use u substitution, right? We can use u substitution. So now how are we going to use u substitution to integrate this? So u substitution, I'm going to let my u to be equals to how much? Let's see. I'm going to let my u to be equals to 2x minus 1, right? So now what is du over dx? Du dx, when I integrate this, du over dx in this case, I'm going to get, let me see, I'm going to get, what is this thing? I'm going to get 1 multiplied by dx, right? So now what I'm going to do over here is, let me see, did I do correctly this thing? X ln of, you see, minus 1, subtract this, and therefore we said that our du is going to be, Oh, I made a mistake here. Before we can integrate, I see why it doesn't make sense. Before we integrate, what we're going to do, okay? You can't integrate equation like this. It's either use your partial fraction or what do? It's either use a partial fraction or whatever the technique that you can think of, right? So now, or your long division method, it's up to you. X ln of 2x minus 1. But me, what I'm going to use, I'm going to add 0 at the top, okay? Because that's a long method that I don't want to use. So I have 2x, I'm going to add 0 based off this number over here. My 0 is going to be negative 1 plus 1. Remember, negative 1 plus 1, it will give us 0. It's mathematical to do so. So at the bottom, I still have the same thing as it is. So basically, you can use your partial, you can use your long division method because the degree at the top and at the bottom are the same. So you can use a long division method. So yeah. So now from here, now what I'm going to do is I'm going to have x ln of 2x subtract 1, subtract, and then here, remember, 2x minus 1 is going to separate. It's going to give, and then divide by this fraction over here. It's going to be 1. And then we have this positive over here, which is going to be 1 over 2x minus 1. Close my bracket there, dx. And then from here, what I'm going to do then, I'm going to integrate this. So here I have x ln of 2x plus, not plus, minus. 2x minus 1 subtract, let's see, what is the integral of x of 1? Gonna have to bring back x. What is the integral of this expression over here? Now, when you integrate something like this, when you integrate something like this, the integral of 1 over 2x minus 1 dx. This is how you're going to integrate this. You're going to use u substitution, okay? So we're going to let u to be equals to 2x minus 1. And then from here, what is the derivative of this? It's going to be du is equals to x, not x, 2, is equals to 2. Why am I being on hurry? So meaning derivative of 2x is going to be 2, right? dx with respect to x, right? So this is what we're going to do. So from this equation, we can see that we can have 1 over 2 du, which will correspond with dx. So what I'm going to do here is here, yeah? I'm going to have positive the integral of this thing. The integral of this 1 over 2x minus 1, which is this thing, right? The integral of this. I said, remember I said the u is this. So meaning I have 1 over u. Ne? And therefore, what is dx? We said dx is going to be 1 over 2. But let me take 1 over 2 here to save time. Multiply by what? Multiply by du. And therefore, from here, I'm going to have x ln of 2x minus 1 subtract x. What is the integral of 1 over u? Remember here we have 1 over 2. We have 1 over 2. So what is the integral of 1 over u? We know it's going to be ln of u, but remember we know that u is the same as 2x minus 1 plus c, which will be our constant right over there. And therefore, that's how we're going to go. Oh. You know what, ne? I made a look here. We have a negative. Be careful about it. Let me do this. Here we have a negative. 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 So this negative will affect this x to be negative. This negative will affect this to be negative as well. We're going to have to distribute that, and then it's going to be like this. And therefore, our constant does not matter. You can write it as positive c over there. Therefore, yeah, hope this was helpful.